So, good afternoon once again. Myself Hitesh Kumar, DGM Technical Delhi Transco Limited, Power Utility. We are handling 400 and 220 kV supply in DTL. So, today's topic is gas insulated switchgear, GIS. So, basically, first of all, I should start the full form of GIS. Uh, it is also written in books, gas insulated substation. But don't be confused. This is not gas insulated substation. It is basically gas insulated switchgear. But engineer can understand. If somewhere it is written gas insulated substation, then automatically we have to correct it. It is gas insulated switchgear. So today's topic I will cover introduction, history and development of GIS, basic concepts of GIS engineering, design criteria of GIS, comparison of AIS and GIS, different interconnection arrangements in GIS, GIS components, CB, CT, VT, surge arrestor, DS, disconnector switch. In GIS technology, we call this disconnector switch, basically isolator, earthing switch, HSES, high speed earthing switch, insulators, etc. Enclosures, specifications and some standards, specification and properties of SF6 gas, production control and interlocks in GIS. Interlocks in GIS as well as in AIS are almost same except the pressure of a GIS or enclosure. They are to be kept in interlock. Otherwise, interlocks are almost same, GIS or AIS. Testing and commissioning of GIS, operation and maintenance of GIS, condition monitoring, hybrid technology, troubleshooting and various site experiences of GIS and some photographs. The slides are 382. So some photographs are there. That's why number of slides are higher. So don't worry. So this is a GIS building, GIS substation. It is of Preet Vihar. How it looks. This is 220 kV GIS hall, and this is 33 kV, and other building are office, etc. This one is the 33 kV. So this is the how it looks, bird eye view. This is the inside the hall. This was from the outside, and this was inside the 220 kV GIS inside the building. How it looks like, I will further explain. This is a make GIS type of event may be there. Bus in vertical plane, 2 buses, bus 1, bus 2 in vertical plane, bus 1 common isolator, and then CT by GIS technology with proper planning, proper design and engineering, erection testing, and GIS substation. All elements have metal enclosed and grounded enclosure except the connection to overhead lines or cables. The main advantage of GIS is its compactness, which has a direct influence on land requirement, land cost, visual impact, and possible technical applications. The compact size offers high variety in design, which in turn allows indoor, outdoor, underground, hybrid, and containerized. A modular design of GIS in connection with its compactness allows specific site requirements to be met. To be met on an extent is possible for AIS. The land area required for a GIS substation is in the region of about 10 to 20% of an AIS substation. AIS, air insulated switchgear, or our conventional switchgear. Considering the switchgear only, the saving in overall land area depends very much upon the specific voltage level and the connection to transformers, reactors, and incoming outgoing lines. Maximum saving is achieved by cable connections and short length GIS trunking. If the substation is connected to overhead lines, then space will have to be allocated to towers and down droppers, which might reduce the total land saving. In most cases, the compactness and reduced area allow the optimum choice of location for new plant substations based on network requirements. For indoor or underground GIS, this is possible even in urban or highly populated areas. Quite often, this will allow building of the substation at the point of consumption, which will bring about significant cost savings in the distribution network. Okay, this is the basically advantage of GIS. In case of hydroelectric power plant, the GIS can be erected close to the turbines, etc., etc. This only theory you can read. I must skip it because this is all advantage as compared to the AIS, air insulated switchgear. The increased demand of electrical power in cities and industrial centers necessitates the installation of a compact and efficient distribution transmission network. High voltage gas insulated switchgear (GIS) is ideal for such applications. The reliable operation of gas insulated switchgear. The important thing is reliable operation of gas insulated switchgear is also based on field proven design principles. Purely mechanical drives, up-to-date computer-aided design methods, comprehensive development and type testing, agricultural principles, architectural principles, and new concepts are applied to develop the GIS for all types of layouts used in electrical networks. It enables new, original, and cost-effective solutions while preserving the necessary operating safety and easy maintenance criteria. The GIS is fully type tested to cover IEC and ANSI ratings and requirement. Basically, in the future, GIS is the basically future of power network. The quality manufacturing and rigorous inspection guarantee excellent service performance. The mechanical assemblies are simple, contain new moving parts. The gas compartments are designed with few joints. Thus, an excellent gas tightness of the equipment is ensured in service. Very important thing, gas leakage to be avoided. The enclosures are mostly made of cast aluminum. They are dielectrically optimized and comply with relevant pressure vessel codes. The aluminum alloys have been chosen for their excellent corrosion resistant withstand against the atmospheric conditions. So GIS can be indoor as well as outdoor also. The switching components are equipped with optic position indicators easily visible from the gangways and optional viewing windows to verify the contact position of disconnectors and earthing switches. This is the important thing. Apart from the indications, we can physically see the position of the disconnectors and earthing switch through the window, whether they are closed or fully closed, or they are open or they are fully opened. So we can confirm it, and it should be confirmed apart from the indications. I will tell you later on why it is necessary to physically check through the window whether isolators or earthing switch they are operated properly or not. Sealing between flanges is ensured by a synthetic elastomeric gasket of a specially designed cross section, providing concentric seals. An excellent long-term gas tightness is achieved. The partitioning of the GIS in gas compartments is optimized for minimum service interference during maintenance, extension, and on-site testing. As far as gasket sealings and gaskets, they have sufficient life, 15 years to 25 years, but during maintenance, whether it is 5 years, 10 years, or 25 years, if you open any chamber, any flange, then gaskets are to be replaced Otherwise, during maintenance, time recommended by OEM, generally 10 to 15 first overhauling, complete overhauling, and after around 20 years, more than 20 years, second overhauling, all the gaskets or parts are to be, gaskets are replaced, parts are to be checked. वहाँ पे ऑडियो आ रहा है कुछ? हाँ, क्वालिटी. The bus bars are consequently partitioned per bay. Each compartment is equipped with desiccant to absorb humidity and gas composition. I will show all these components, photographs, a pressure relief device, a density switch or sensor to measure gas density, and a filling valve. All connecting conductors are made of aluminum or copper, silver plated at the joints to minimize the contact resistance. The contacts are of the sliding type, almost no nut and bolt, sliding type, tulip type contacts are there. During contraction and expansion, they can slide. No mechanical stress is developed. And to avoid that mechanical stress, in the enclosure, bellow type arrangement is there. I will show all these in pictures, photographs. To allow expansion without transmitting mechanical forces to the support insulators, finger or tulip contacts are used for dynamic contacts and tungsten protected contacts for short circuit and load switching contacts. Safety. The encapsulation of GIS provides a high degree of safety for operators and other personnel due to the fact that it is impossible to touch any live part of the switch gear inadvertently, i.e. without the use of tools or extreme forces. Nobody can reach up to the live parts of the GIS. No one can commit suicide in the GIS. Fully safe. Protection against vermin or vandalism is also provided. Nothing can enter in GIS or live parts. The consequences of an internal arc are normally contained within the enclosure through rapid operation of the protection. Even under worst case condition, it is limited to the operation of a pressure relief device or a burn through after certain time. No GIS part will explode and the damaged region is limited by the gas compartmentalization. Even in the blast or in the during mal operation, there is no explosion in the GIS enclosure. They are designed for that. Rarely it happens. History and development of GIS technology with SF solution is well established technology in service since the 1960s. The metal enclosure concept first used at high voltage in the 1920s. So this is all GIS development started in 1960s, and as on today, with the addition of the new technologies, and this is going on. The overall SF6 gas leakage rate is reported to be 0.4 per year, but now it is 0.1%. This is the just history in which year from 1960s to 2001. I have some history. Okay, I am skipping this. Due to growing demand of power, the large transmission corridor is required. A considerable large built-up area is required in the generating stations for setting up a substation for transferring this large quantum of power through EHV transmission lines. The land build-up area is generally not available, particularly on highly hilly terrain. GIS is the only option for transferring the power from underground power stations. GIS installation is very advantageous in case of urban areas, underground power stations, places where environmental conditions are important. Keeping in view the advantage of GIS installation, the cost of GIS coming down to about 1.5 times of AIS with almost zero maintenance of GIS. In case of breakdown, the cost becomes high, but otherwise almost zero maintenance for 10 years. Put together with non-availability of land in cities, urban areas, soaring of land prices even in the rural areas, besides difficulty in acquisition of land, one can infer that the future lies in GIS installation, and in metro cities, land is not available, only option is GIS. We are facing this problem in Delhi. So this is CB Open. I must show you this hydraulic, how these works basically. I must show you the video. Anyone can tell me whether a video is visible to you?
Yes, sir. Yes, sir.
Okay, so I should start again. Okay, I will repeat you how the hydraulic system works. You just see and I will tell you. So this is our charging operation. So you can see that this motor is running. This is our motor. This is a small pump, hydraulic pump. And this hydraulic pump, the size of the hydraulic pump is less than 4-5 centimeter. The size of the hydraulic pump is less than 5-7 centimeters. क्या चीज का एग्जांपल मैं इनको दूं? Okay, so this is our motor. It is charging, and this blue color is the aisle, basically low pressure aisle. Blue color means aisle without any pressure, or you can fill the aisle here. This motor will push the aisle, and this aisle will go here. Red color means high pressurized aisle. When this aisle will be coming here, and this all the springs, it will come up. Means spring will charge. So first spring will charge and it will store the energy. So see again. Springs are going upward and it has stored the energy. Now closing coil will work. You see this closing coil. This aisle will come from here to here and it will push it up. Now your breaker is closed. And again, this has compensated that energy by again pushing the low aisle pressure to the high aisle pressure. Now see the tripping action. This high pressure aisle and low pressure chamber, that is short circuited, means the pressure which was here higher pressure earlier, that has gone to the low pressure chamber from here to here, like that. This aisle has gone from here to here and it is operating. Now another thing is we can release the pressure. By the way, springs are charged and high pressure aisle is there. We want to work on the circuit breaker. We have to discharge the spring. So for discharging the spring, there is the non-return type valve. If I mix this high pressure aisle to this low pressure chamber, then all this aisle will come to the low pressure aisle and this spring will discharge automatically and this will go down and this spring will discharge. So see how this spring is being discharged. Already discharged.